Hello, everyone. My name is John Cardenas. This is assignment number 6 for the Toyota production system. Chapter 8, Principle 2. Create continuous process flow to bring problems to the surface. I want to start Principle 2 with this important statement from Minoru San, former president of Toyota Motor Manufacturing of North America. If some problem occurs in one-piece flow manufacturing, then the whole production line stops. In this sense, it's a very bad system of manufacturing. But when production stops, everyone is forced to solve the problem immediately. So team members have to think, and through thinking, team members grow and become better team members and people. This statement from Minoru San gives us an insight of what a one process flow is, but also how to identify and find problems in the manufacturing line. Teamwork approach to problem solving is a key component of the process flow improvement. Key components of continuous process flow. MUDA. MUDA translates to wastefulness, uselessness, and ineffectuality, which is a contradicting value addition, net A. Value-added work is a process that adds value to the product or service that the customer is willing to pay for. Under MUDA, we have two categories. We have MUDA Type 1 and MUDA Type 2. Under MUDA Type 1 includes non-value added activities in the process that are necessary for the end customer. For example, inspection and safety testing does not directly add value to the final product. However, they are necessary activities to ensure safe product for our customers. MUDA Type 2 includes non-value added activities in the process, but these activities are unnecessary for the customer. As a result, MUDA Type 2 should be eliminated. So the big difference between Type 1 and Type 2 is that MUDA Type 1 is necessary, where MUDA Type 2 is unnecessary. Under MUDA Type 2, we have identified 7 ways. The acronym for these are TEAMWOOD, which is easier to remember. So the first one is transport. The second one is inventory. We have motion, waiting time, overproduction, overprocessing, and defects. Non-value added, net B, are the tasks necessary or unnecessary during the manufacturing process. MORI. It means to overburden beyond one's capabilities. Unchecked MORI can result in employee low morale, retention issues, and safety concerns. For equipment, it can lead to continuous breakdowns and even catastrophic process or cell failure. MURA. It means unevenness, non-uniformity, or irregularity. MURA is the reason for the existence of any of the 7 ways. In other words, MURA drives and leads to MUDA. In this example, we clearly can visually see the difference between MURA, and MUDA. So for MURA, we see this little truck where there is overburden with load, probably more than it can carry, and that's a no good situation. For MURA, which is unevenness or variation, we can see where the load is uneven. MUDA is where we have more than what we need. We probably could carry the load in 2 trucks, but we added a third one. And then a non-MURA or MUDA situation is where it's perfectly balanced. Process flow efficiency enhances manufacturing capabilities by reducing cost, waste, and lead times. Flow. It means that when your customer places an order, this triggers the process of obtaining the raw materials needed used for that customer's order. Batch processing. The emphasis is on producing small batches of products or components in response to customer demand or a pull system, rather than large fixed batches in anticipation of demand, push system. Takt time, the heartbeat of one-piece flow. Takt is the German word for rhythm or meter. Takt is the rate of customer demand. Producing goods ignoring customer demand leads to over or under production, MUDA type 2. Excess inventory or bottlenecks. Here is a graphic representation of a takt time or resumo. This is a no good situation when there is no rhythm, and this is a good situation when there is rhythm and harmony. Process flow efficiency enhances manufacturing capabilities by reducing costs, waste, and lead times. Continuous process flow definition, objective, and benefits. Definition. The second principle encourages manufacturing organizations to design, test, layout, and optimize all the processes or cells. In this way, we can apply flow improvement, batch processing, and rhythm. It is crucial to incorporate into each process systems that enable its workforce to easily identify inefficiencies, MUDA, MURA, MURI, before those are transferred to the next customer, internal or external. So what is the objective? To encourage transparency and rapid problem solving at the earliest possible stage of the manufacturing flow, ultimately improving the efficiency and effectiveness in all manufacturing daily operations. So what are some of the benefits of continuous process flow? Enhances efficiency, productivity, and flexibility. Enhances quality by capturing issues early in the manufacturing flow. Reduces waste, costs, and lead times. And enhances quality by allowing for immediate identification and resolution of all issues. Process flow efficiency enhances manufacturing capabilities by reducing cost, waste, and lead times. Continuous process flow key points. Continuous process flow. Work processes are organized and structured to minimize interruptions, bottlenecks, and delays, ensuring a steady and uninterrupted flow of work from one stage to another. This does not necessarily stop the production line, only the impacted areas by utilizing area buffers. Quick problem detection. The smooth flow of work helps in identifying problems or abnormalities as they occur, allowing immediate attention and resolution. Empowerment and accountability. Teams and individuals are empowered to stop the production line or process when they identify an issue. This promotes a culture of accountability and problem solving at the source. Continuous flow includes the product's final destination or customer. Here is an example of continuous process flow. In a manufacturing setting such as Toyota's own assembly line, the concept of continuous flow is essential on daily operations. Each workstation or process is synchronized to ensure a steady delivery of parts. This in return minimizes idle time and production delays. Any issues, defects, or deviation from the specs are identified before transfer occurs to the next line. In addition, data is gathered and analyzed to prevent recurrences and to apply permanent countermeasures. Principle 2. Production lines have the potential to foster a culture of continuous improvement and problem solving, resulting in higher operational efficiency and customer satisfaction. Benefits of continuous process flow. The first one is built-in quality. By promoting a culture of accountability and problem solving at the source or station, each operator can fix, report, contain quality issues before those are passed down the line. Creates real flexibility. If equipment and processes are set out around one specific product, this will limit manufacturing flexibility. But on the contrary, if lead time to manufacture goods is less, this in return will allow greater flexibility to adjust to customers and market demands. Creates higher productivity. Under one-piece flow, it is easier to identify each operator value and non-value added time, net A or net B. It is easier to identify bottlenecks as well wasted time, MUDA. Quality, flexibility, and productivity are key benefits of one-piece flow. Frees up floor space. By design, one-piece floor approach utilizes better available space by pushing everything together to the cell. This in return reduces unnecessary inventory and waste space. Improves safety. By default, one-piece flow reduces safety risks and incidents by minimizing traffic of forklift, toggers, or personal operated vehicles. Additionally, less inventory means fewer tripping hazards. Improves morale. Incorporating flexibility and productivity increases value added to processes, which in return gives the operators a sense of accomplishments and job satisfaction. Reduces cost inventory. Unused inventory is an operational expense that can divert capital to other investments, essential to stay competitive. Floor space, safety, morale, and cost inventory are key benefits of one-piece flow. Continuous process flow strategies. Value stream mapping. Identifying and analyzing the entire value stream to eliminate non-value added or net B activities. Optimizing the flow of value adding steps to create a seamless process. Using time, JIT. Producing only what is needed, when it's needed to avoid overproduction and inventory waste. Reducing lead times and costs while enhancing responsiveness to customer demands. Value stream and JIT are critical tools to eliminate Muda, Muri, and Mura. Implementing continuous flow. Kaizen, continuous improvement. Definition. Continuous improvement activities that involves everyone in the organization. Concept. Encouraging employees to suggest and implement small incremental improvements regularly creates a sense of accomplishment and job satisfaction. Example of Kaizen. Event focus on a specific process to improve efficiency and flow. Involvement of cross-functional teams to quickly identify and implement improvements. Recap of Principle 2. Create a continuous process flow to bring problems to the surface. Creating a seamless and uninterrupted flow of work. Minimizing waste, delays, and disruptions. Build what is necessary. Rhythm. Create a quality culture. Takeaways. Enhance efficiency and productivity and quality. Reduce waste and costs. Improve customer satisfaction and loyalty. Principle 2 underlines the significance of maintaining a steady, continuous flow of work to reduce inefficiencies, save time, and enhance overall productivity. Chapter 11, Principle 5. Build a culture of stopping to fix problems, to get quality right the first time. I want to start Principle 5 with this statement from Sho San, President of Toyota Motor Corporation. Mr. Ono used to say that no problem discovered when stopping the line should wait longer than tomorrow morning to be fixed. Because when making a car every minute, we know we'll have the same problem again tomorrow. In other words, as Abraham Lincoln put it, leave nothing for tomorrow which can be done today. These two statements give us an insight of what Principle 5 is all about. Problems of today become the monsters of tomorrow. Definition, objective, and benefits of principle number 5. Definition. The fifth principle encourages manufacturing organizations to be proactive to daily quality challenges by encouraging among its workforce a mindset of problem solving and quality assurance. In other words, when a problem or defect is identified in the production line, the operation should pause or stop to resolve the issue at its source, rather than allowing it to propagate down the line. Objective: to establish a work environment in which all workforce is encouraged and empowered to address and rectify issues immediately as they arise in the process. Both of these are a cultural mindset within the organization. So what are some of the benefits of this culture? Reduction of defects, minimize rework, lower production costs, a culture of continuous improvement. This also enhances customer loyalty and satisfaction. Simplify operations, save resources, and most important, produce high-quality products, resulting in better competitiveness and customer loyalty. Brand recognition, brand and quality associated as one. A proactive culture is a more efficient because problems do not pile up or are kicked down the line. Key components of the fifth principle. Jidoka. It means that the process which is created any issues is consequently evaluated to remove the possibility of recurrence, permanent countermeasures, and learning. Under Jidoka, there are two kinds of Jidoka. The first one is mechanical Jidoka. It is the principle of designing equipment to stop automatically and to detect and call attention to problems immediately wherever they occurred. Human Jidoka. Team leaders and operators are equipped with the means to stop the production flow wherever they find anything suspicious, thereby preventing the waste that would result from producing a series of defective items. Jidoka is a key component of the Toyota production system. Key components of the first principle. Andon. A visual aid signal that highlights where action is required. It is a typical tool in applying the Jidoka or autonomization principle, which means highlighting a problem as it occurs in order to immediately countermeasure the issue and prevent recurrence. Genchi Genbutsu. The best practice is going to the spot, location or process, and see for yourself the problem to truly understand the root cause and solve it. Andon is the signal for help. Genbutsu is the reaction to fix the problem at the spot. Another key component of the fifth principle is ANG's why 5 times, or as is more better known as the 5P. Here is an example of a 5P. The first portion is the problem definition or discovery. This clearly highlights the who, the what, where, when, why, how, and how many. This post this is pretty much the 5P itself. Identify the true root cause of the issue, which usually leads to what we call the systematic failure, which is either human error or a procedure that is not in place. Some of the tools utilized for 5Ps are the fishbone, will help us to narrow down if the root cause of the issue is under method, man, machine, or material. This same concept is applied by the TPS. So asking why 5 times when a problem is found will provide a root cause analysis as well as a countermeasure. Quality as a foundation. Quality is the foundation of Toyota success. Probably the best description that I found on this chapter for Principle 5 was in an interview to Gary Cummins, president of Toyota Georgetown factory. As he explained, when I was at Ford, if you didn't run production 100% of the shift, you had to explain to division. You never shut the line off. We don't run 100% of the scheduled time out here. Toyota's strength, I think, is that the upper management realizes what the Andon system is all about. They have lived through it and they support it. So in all the years I have been with Toyota, I have never really had any criticisms over lost production and putting a priority on safety and quality over hitting production targets. All they want to know is how are you solving problems to get the root cause, and can we help you? I tell our team members that there are two ways you can get in trouble here. One, if you don't come to work. Two, if you don't pull the core. If you got a problem. The sense of accountability ensures quality at each station is critical. Unfortunately, many manufacturers don't follow this principle. It seems like numbers and production targets are more important than quality and safety. Really, to follow in Toyota's footsteps, the Andon system and the culture of stopping the line to fix the problems needs to be a priority. Quality and safety are a culture that must be cultivated and encouraged by all team members. To enhance on Gary's previous comment, quality is the foundation of Toyota's success and reputation in the automotive industry. In addition, Toyota is renowned for its commitment to delivering high-quality vehicles to its customers. This commitment is deeply rooted in its manufacturing philosophy, pillars. As I have described in Principle 5, building a culture for stopping to fix problems to get quality right the first time. A great example of Toyota's commitment to quality is how it handles product recalls. When quality issues arise, Toyota often recalls vehicles voluntarily to rectify any defects, demonstrating its unwavering commitment to customer safety and satisfaction. This focus on quality has not only solidified Toyota's reputation for reliability, but has also set a benchmark for the entire automotive industry. As an example, we see that for 2023, there is actually a Toyota recall. It's a voluntary Toyota recall for the Tundra models. Takeaway for this is build a culture of stopping to fix problems to get quality right the first time. Challenges. Implementing Principle 5, build a culture of stopping to fix problems to get quality right the first time. In manufacturing can present several challenges. For culture, one critical challenge is the cultural shift required within the organization. It often demands a change in mindset from both employees and management, as many traditional manufacturing environments prioritize continuous production over stopping for problem solving. Encouraging workers to help production to address issues requires a shift towards more proactive and problem-solving culture, which can be met with resistance and skepticism. Another challenge is the potential for disruptions in the production process, as stopping to address problems can impact output and efficiency targets. In the short term, balancing the need for immediate issue resolution with production targets in a constant challenge. Additionally, identifying and addressing the root causes of problems effectively demands time and resources for training and skill development, which can be a challenge to implement in some organizations. Overcoming these challenges is essential for achieving long-term benefits, including improved product quality, reduced costs, and enhanced customer satisfaction. Conclusion. In conclusion, principle number 5 is the cornerstone of the effective manufacturing and quality management. It highlights the importance of addressing issues at the source and encourages a mindset of proactive problem solving. By making immediate problem resolutions a core part of the organizational culture, this principle ensures that product meet or exceed quality standards from the start, reducing defects, cost, and customer dissatisfaction. It fosters a sense of ownership, employee empowerment, and continuous improvement, leading to a more efficient and customer-focused manufacturing process approach. Ultimately, it enables organizations to produce high-quality products consistently, enhancing competitiveness and customer trust and therefore loyalty. Conclusion. The commonality between Principle 5 and Principle 2 is that one stops the problem, the other one identifies the problem. Uh, Ultimately, both have the same goal, which is achieve 100% quality for the customers. Um, so some of the strategies to achieve this common goal is starts with a leadership commitment to a culture of quality, communication channels, which communication has to be consistent and clear for all levels of the organization. Create a quality culture from the top all the way down. Develop standards. Establish quality key point indicators. Also, to have strategies for continuous training. That is something that is very important in quality, continuous training. Process improvement, unknown systems or signals to identify quality issues and how to stop them. Continuous improvement and shared knowledge and create a database of past problem history. Create the culture and tools to easily identify issues at the source. Is very important to achieve the quality goal. Thank you for your time. Have a great night.